In this video, we're going to take a look at the intersection of lines with planes, okay? And so in this scenario, there are three possibilities of how a line and a plane can intersect. And the first scenario is the line intersects the plane at one point. So picture we have a plane, you can think of that like a piece of paper, and then I have a line that runs through that plane. So that's my line. Okay, so the next scenario would be that the line is parallel to the plane and there are no solutions. So that would be like having the plane over here, that's my plane, and then having a line somewhere below, above, beside the plane. And the last scenario would be the line lies in the plane. So then, of course, there are infinite solutions. So there's my plane, and somewhere within that, there's my line. Okay, and we're going to look at how we actually go about figuring out the number of solutions and the actual solutions. And it's actually a fairly simple method. If you look here in this example, you can see that in the line, we're given the parametric equation of the line. And here for the plane, we have the scalar equation of the plane. And I hope it sort of makes sense to you that a very simple method, we can take this x, y, and z, we can sub them into the plane, and we can solve for t. Okay, so that's our method. Let's write that down. So we're going to substitute parametric equations of the line, parametric equations of the line into the plane. Okay, and you'll see what happens when we do that. So let's go ahead and do that. You can pause the video. I'm sure you could probably do that by yourself as well. Okay, so that's what it looks like when I go ahead and sub those parametric equations into the plane, and you pause the video and go ahead and solve for t. Okay, so check your work there. You should have got t equals -1. Now, I want you to think about what this could mean, okay? What does this mean in this scenario? Okay, so this means that when t equals -1, that is the point of intersection, and we can find the point, the x, y, z of the point, by subbing that -1 into the line. Okay, so let's go ahead and do that. So this means when t equals -1, that is the point of intersection, meaning, of course, they intersect at one point, and there is one solution. Okay, so let's go ahead and just find that point. That, of course, means x equals 5 plus 2 times -1, so x equals 3. Y equals -5 minus 5. That would be 0. And for z, we have 2 plus 3 times -1, so z equals -1. Okay, so therefore then, there is one point of intersection, and we can say that the point of intersection is 3, 0, -1. Okay, so that's what it looks like when there's one solution, and that's how we actually go about solving. We still don't really know whether that means this scenario where they're separated, where they're parallel and we'll call it distinct, or whether it means the line is within the plane, so they're parallel and what we call coincident. Okay, so the way to check that. Okay, so now what I want you to do for B and C is I want you to use that method. I want you to pause the video. I want you to try it on your own, use the method, and I would want you to pause when you think you're stuck or you're not sure what it means, okay? So do both B and C, pause the video, use the method, and stop when you think you're done or you need some help with that. Okay, so taking a look at what you got for B there, I hope that when you used the method and substituted the parametric equations of the line into the plane, you solved and you got 0t equals 31, okay? And you've seen this whole scenario before, and this always means no solutions, right? I want you to remember that this is never true, right? 0 times some number t will never equal 31, and this, of course, like we said, means there's no solution. So think about the three scenarios from the beginning, okay? That would mean that the line is parallel to the plane. Okay, that's the scenario there. That's what you would end up with when you went ahead to solve. Okay, looking at C, you'll notice one little trick here. You do need to take your line and write the parametric equations from the vector equation if you want. You can go right into the work, or you can write them at the side, okay? So again, pause the video if you haven't to make sure you've got C solved as far as you can on your own. Okay, so looking at this scenario, I hope that when you simplify, you can see that you get 0t equals 0. Again, we've seen that idea before, and we know that 0 times any value for t will always equal 0, so that is always true. Okay, so what do you think that means? That would mean there are infinite solutions. And in terms of the scenario, that means the line lies in the plane. I hope you can see that, and I hope that makes sense. Okay, so that's simply the method. There are three possible scenarios. Okay, and so in example 2, I just want to show you that you can actually determine if the line intersects the plane without even solving. Okay, so note the words here on this question. Without solving, we're going to determine if there is an intersection or if there is not. Okay, so let's take a look, using example 1, we'll take a look at the information that we have. Okay, so we've been given our line and our plane. Right from that, you can see that the direction vector for the line is equal to 3, 2, 1. And the other piece of information that you're given is you're given the normal of the plane, right? And that would be 3, -1, 1. And I hope you can see that from those equations. Now, if we take a look at dotting the direction vector with the normal, we see that we would get 9 minus 2 plus 1, so we would get 8. Now, because this is not 0, okay, we know that the line and the plane are not parallel, and so they must intersect then. Okay, so this would mean that there is, of course, one solution. Okay, now you pause the video and take a look at what happens in B. Okay, so in B, I hope that you can see that the direction vector of the line is equal to -2, 1, -4. The normal of the plane is equal to 4, 0, -2. And when I dot those two together, I get -8 plus 0 plus 8, and you can see that you get 0. Okay, now what does this mean? This means that the line and the plane are parallel. Okay, now we still don't really know whether that means, I'm just going to scroll back up here. Oh, sorry. Would be to check to see if this point from the line lies in the plane or not, right? So we're going to test to see whether the point 1, 0, 1 lies within the plane. Okay, so we're going to test. Sorry, we want to know whether it's parallel and distinct or coincident. So we're going to test the point 1, 0, 1 in the plane. And since the plane's a scalar equation of a plane, very, very simple to do that, right? Left side is 4x minus 2z minus 11. Let's plug in the point. 4 times 1 minus 2 times 1 minus 11 is -9. So we can see that the left side does not equal the right side. Okay, and therefore then the line and the plane are parallel and distinct and there are no solutions. Okay, so I hope that makes sense. There's some practice listed there, page 479 for you to do with this, just to test out this method and make sure you've got the understanding.